let's go back then. So let's see. Let's just take these first three. What in the world does that look like to you based on our conversation yesterday? Does anything look like it's familiar? Does that look like an ionic or covalent compound?
Mm-hmm.
We were talking about this yesterday in lecture. And you got to have a periodic table to answer that question.
Is it covalent?
Mm-hmm. It's covalent, right? In fact, then what about this one, ionic or covalent?
Covalent, I thought. Or is it not covalent?
I thought my audio cut out there for a second, Kirsten. I thought you said ionic. Did you say ionic?
Okay, I'm a little bit confused now.
Okay. Why
Okay.
why would I expect you on the final to know that guy's ionic?
Because it's
You got to look at a periodic table. Do you have a periodic table? That's how you're going to answer that question.
Yeah, it's metal with a non-metal.
Perfect answer. That's what I would give. Yep. Sodium's a metal and chloride's a non-metal. Mm-hmm. This is hydrogen's a non-metal and iodine's a non-metal, so that's a covalent compound. All right. From yesterday in lecture, and maybe Eli, you can chime in. Kirsten, maybe you can chime in too. What was the business end of an acid? If I get an acid in my eyes, ouch, it hurts. How do you recognize an acid if you were to see one?
Acids tend to be the covalent compounds.
Okay, is that all?
We know that they give away ions, or they like to give ions.
Any ions or ion in particular? If you're an acid, is there a particular ion that dominates your properties?
H plus.
Yep. And so here's what the homework is asking you to do on this one. Okay. The homework is saying they expect that you recognize that this guy's covalent. They also expect that you recognize that this guy looks like he's got an H in the formula. This guy looks to me like he could be an acid. And so this guy, if he was an acid, what ions would it make in water? I mean, I know it's covalent. I get you. But it will make ions. What ions in particular?
H plus and
right.
I minus or negative.
Uh-huh. And which of these two will cause blindness in children? If you got that in your eyes, which one will cause blindness?
The iodine?
Not so much. It's probably not good to have iodine in your eyes, but one will cause blindness faster than the other. Which one?
I guess the hydrogen.
You betcha. So that's a big problem, because that would mean if you got that in your eyes, the pH of your eyes would drop dramatically, and your protein in your eyes would be unhappy, and unhappy proteins in your eyes is not good for vision, as you can imagine. All right, so how are we doing? So what do you think about A? Acidic, basic, or neutral? Which one do you think?
Acidic?
Yeah,
definitely acidic. Okay, so they're expecting this. You can't read it. It says acidic. Okay, they're expecting. Okay, all right. What about B? I'll sit here and I'll shut up for a little minute. Once you think about B, what do you think I'm a B?
Wouldn't that be either basic or neutral?
Okay, I like it. I like what I'm hearing. Tell me why, Kirsten, you don't think it's acidic.
Because I know that that's sodium, and that's something that we can eat. Well,
Good point.
Yeah.
Okay, I love that. That's really good thinking. You're exactly right. Things that you and I eat tend to be relatively safe in pH. I mean, there's some things that you and I eat that are really acidic, like oranges and lemons.
Yeah.
Citrus. Okay, they are, but salt doesn't have that sharp taste like an acid or a base would have. Okay,
Yeah.
like a citrus fruit would have. Okay, so I love the logic. Any other reason why you think that would be not acidic? So Kirsten voted for, we got 2 votes now. We got either, she said either basic or neutral. And I'm here to tell you it's only one of those. Not both, it's only one.
Basic.
Okay. To be basic, what was the quality of a base? Ouch.
I mean, not basic, neutral.
Okay. All right. You changed your answer. Why'd you change your answer?
Because it's, I don't know. I just feel
No,
like
no, you know. If you get base in your eyes and it causes blindness, what ion is in a base that causes blindness?
OH.
Yeah. And if you go back, do you see OH in that formula?
No.
I don't either. So which one do you want to choose? Neutral or basic?
Neutral.
Okay. All right. Okay. All right. Let's try this one. What's your vote on that one?
Basic.
Yep. How come?
It has the OH.
Uh-huh. And is this one ionic or covalent?
Ionic.
Yeah, I heard ionic. And how do you know it's ionic? Because I agree.
I thought OH was ion.
Good point. Sure. Good point. But wait a minute now. Wait. If I give you, let me give you a different example. Let me give you a chemical like this. This is methanol, which is wood alcohol. That's got an OH in it. This compound is covalent or ionic?
Is it not ionic?
Nope. How do you know that one's not ionic? Everybody got to remember your periodic table. How do you know it's not ionic, therefore covalent? How do you know?
Is it 2 nonmetals?
Mm-hmm. In fact, it's 3 nonmetals, 3 different nonmetals, right? Mm-hmm. So if I come back to that example that you and I were looking at, this has got a whole bunch of nonmetals, right? Mm-hmm. But didn't you memorize some time ago this ion, right?
Yeah.
Didn't you memorize that? And so this compound has these 2 ions as part of it. And so this is definitely ionic, which means it's going to make hydroxide ion, and that guy definitely will be a base. No doubt about it. No doubt about it. How are you with ABC?
Oh, okay. Okay.
Okay. Here's what I want to do now. These, you're going to have to use a calculator to answer that question. All right. So let's take one. Okay. Let's take this first one. Okay. Let's go onto a piece of paper. 10 to the minus 8. Let's see. Okay. So let me see here. They said H plus, molarity of H plus is 1 times 10 to the minus 8 molar. And you got to decide acidic, basic, or neutral. You got to decide. How in the world are you going to decide that?
I assume by the 10 minus negative 8.
Yeah. But I mean, there's a calculation involved. How are you going to decide that? What are you going to do?
Okay.
Is there anything like don't you also have to know what this is?
Yeah.
And what would that be?
6, 10 to the
Yeah, I heard it. 10 to the negative 6. Are y'all both convinced of that? Because this times that will be 10 to the minus 14, right? Eli, you okay with that?
Yes.
Okay. So now, the 2 of you, which one's larger or are they the same?
The negative 6.
So which one's bigger, hydroxide or H plus?
Hydroxide.
Yep, this is bigger. So what's our answer?
Base.
Yep, definitely basic. Anytime the one's larger than the other, it's basic. Okay. So let me come back here. Now what I want to do, I'm going to assign these. Let's see. I'm going to PD. I will do F. E will be Eli. And G will be KG. Okay.
Mhm.
Take a minute, get your answers, and we'll meet back here in a second. I got to get my calculator out. Okay, I got my answer. Eli, got your answer?
Yes.
Kirsten, you got an answer?
Yes.
Okay. Eli, give me your answer. Acidic, basic, or neutral?
Basic, because OH is larger.
Okay. And so just checking, what was the H plus concentration in this one?
10 to the negative 12.
Okay, good. I like it. Kirsten, what do you think?
I got acidic.
Mm-hmm. How do you know? What was the H plus concentration?
1 times 10 to the negative 12.
Wait, that's hydroxide. What was H plus?
To the negative, to the second. Oh, my.
Okay, good. That's I had. Yeah, okay. All right, I like that. So what do you think about this one? I did my calculations. Let me see here.
Neutral.
Okay, got 5 times 10 to the minus 7 molar. That's the molarity of the H plus. Equals that. So I got to do the math. 5 times 10 to the minus 7 molar times the molarity of the hydroxide, equals 10 to the minus 14. And if I solve for that, molarity of the hydroxide, the math that I got was I got 2 times 10 to the minus 8 molar.
So confused how you did that.
Well, I divide this into that. Do y'all know how to do that on your calculator?
Okay, let me see.
If you're using like a TI calculator with one of those screens, you better make darn sure that you're putting parentheses like crazy. Okay. So the way that I would enter that on my, I mean, you don't need a fancy calculator like that. I'm just using my phone. The way that I would enter that on my calculator is I probably would do 10 to the minus 14. Let's see, I'd probably do the caret 10, caret minus 14, and I'd put parentheses like crazy. And I would divide that by parentheses like crazy. 5 times, which would be star, 10 caret to the minus 7. You got to make sure you put this and make sure you put parentheses around your guy. And when you get it, you're going to get 2 10 to the minus 8 molar. So let's not leave until you're both convinced that you can do that confidently on your calculator.
Okay.
Another nice little trick that I learned that makes it a lot quicker and easier is that if you're doing 10 to the whatever, whenever you're multiplying two numbers that have 10 to the blank, if you add the two blanks together, then that'll be your answer.
Yep. When you multiply powers, you add the exponents. In this case, I'm dividing though, right?
Yeah, so you just
subtract. Yeah. So what Eli, I think, is suggesting is another way to write all this is 1 over 5. So it's 1/5 times 10 to the minus 14 divided by 10 to the minus 7 if you mess around with the algebra. And 1/5 makes it 0.2, and this makes it 10 to the minus 7. But when I move the decimal over one place, then I get 10 to the minus 8 up there.
Okay.
How y'all doing?
Okay.
Right. Is there not like an easier way to, so is this acidic, basic, or neutral? I forgot to ask you. This is the molarity of the H plus, and this is the molarity of the hydroxide. Which one? Acidic, basic, or neutral?
Acidic.
Yeah, a lot or a little bit?
A little bit.
Y'all see that? It's just a little bit acidic. But nonetheless, they didn't say whether it was a lot or a little bit. This one's definitely acidic, not by much, but definitely. So now I got to ask you a question. Can you think of any easier way for us to do all this? And in order to answer that question, I need a fresh copy because that was a mess. Okay, let me go get a fresh copy of that homework. Okay. Get a fresh copy. Okay, got it. All right. There is no easier way to do these. So we've already done those the only way that you can possibly do them because there's no numbers. Okay. What you and I are going to do down here is we're going to do this another way. Let's do it in pH. Okay? That's what I want to do. I want to do it using pH. Let's go back then, back to my page right here. And I want you to notice something, okay, what the idea of what pH stands for. Let me mess this up. Okay, here we have this equation. We're okay with that. And do y'all know what a teeter-totter is?
Yeah.
Yeah.
Okay, I wasn't sure if people, because it's kind of an old toy that I played with when I was a kid. But the idea of a teeter-totter is both sides of a teeter-totter can't go up at the same time, can they? If one side goes up, the other side has to go down. If the other side goes up, the other side has to go down. And I like to use that as an analogy when you're comparing the concentration of this guy and this guy in a glass of water. If this goes up, this has to go down, so they both equal to that. If this goes up, this has to go down, so they both equal that. And when they're exactly level, exactly equal to each other, that means these two are equal to each other. Watch what happens. That means they're both equal to the same number. And if I solve for x, x would be the square root of 10 to the minus 14 there. That means x equals 10 to the minus 7 molar. If this and this were both that number, then their product would be 10 to the minus 14. This is where that is coming from. And so I got to ask you, do you see any relationship between these numbers and the H plus concentration? Is there any relationship to it? Is this 7, does it look anything like 10 to the minus 7? How is it related? You can see it. Because that's where that letter P comes from.
So the number on the scale is equal to the negative version on generating 10 to the blank.
That's it exactly. And the P on pH stands for power. Okay? And it's sort of like the power of hydrogen. Okay? If you will, is where it comes from. Power of the hydrogen ion. And so it's not exactly equal to the number, it's the changing the sign, isn't it? Right? And so that means if I have a nice round number like this, you know, H plus is 10 to the minus 1. If H plus concentration molarity is 10 to the minus 1, this 1 right here is my pH. pH equals 1. If I have 10 to the minus 2, that's 2. If I have a really, really low number, these are really, really low, that 13 is 10 to the minus 13 then. So when people invented the pH scale, what they did was they invented a scale where you could take huge ranges of concentration. I mean, the difference between this guy and this guy is a million. So something that's pH 13 is a million times more basic than stomach acid. Okay, so it's powers of 10. Exercise, it kind of put in a very, very small scale. Okay, so what you and I are going to do now, let's take that idea and let's go back and see if we can't do that same thing. We got the H plus, don't we? And the 1 doesn't change this math in any way, does it? So I'm going to erase it. We don't need it. What's the pH of this solution? H plus is 10 minus 8. What'd you get?
8.
You okay with that? Now let's go back and check our scale. Kirsten, you said there was something magical about 7, didn't you?
Yeah.
Is 8 basic or acidic?
Basic.
Isn't that what we said?
Yeah.
All right, go back. Let's see. What's the pH on this one?
2.
Don't need that one. Careful now, that's hydroxide. You can go back and check your math. What was our molarity of H plus? It's got to be H plus, okay?
Okay.
What was it? Go back and look and see.
12 or negative. It was 10 to the negative 12.
This was, yeah, it was 10 to the negative 12. So what's this pH?
12.
12. Is that acidic or basic?
Basic.
Yeah, let me go back and check. Is it highly basic or just a little bit basic?
Highly.
It's obscenely basic. All right, let me go back. What about this number? What was the pH that corresponds to this one? What was the molarity of H plus? Really important that you realize that when it's pH you're talking about H plus concentration.
Okay.
What was this one?
2
to the minus
2.
Yeah. And so what was our pH?
2.
Acidic or basic?
Acidic.
Okay. Okay. Now this is where we're going to need your calculator. What the heck do we do with this one? We've already decided this was acidic or basic. What was our answer on this one? We said this was basic. That one was basic. That one was acidic. What was our answer on this one?
It was basic.
Yeah, we got basic for that, didn't we? Okay, so let me go back. All right. Need a piece of paper. All right. So I got H plus molarity is 5 times 10 to the minus 7. And this is not 1 anymore, so the math will not be quite as simple, but it's almost as simple. We got to do one more equation, everybody. I'll see that equation. How many of you remember logarithms from algebra? Do you remember that?
Somewhat.
You got the log button on your calculator, right?
Yeah.
Okay. So I want to take that equation. Let me go back. I want to write that down. pH is minus the log of the molarity of H plus. All right. So everybody get it on your calculator. That means the pH is going to be minus the log, base 10 log, of this number right up here. So if I was entering that on my calculator, I think the way you do it on it depends on your calculator. But if you got those TI calculators, I would enter minus the log, base 10 log, of 5 times 10 to the caret minus 7. Don't forget the minus. Do y'all have a number? Make sure you use parentheses, man. Don't leave them off. If you don't put parentheses around that, your calculator will explode. Well, I mean, it might explode. I can't be responsible for damage to your calculator. We got a number?
Yeah.
What'd you get?
I got a 6.3.
6.3. Okay. So let me go back and check. 6.3 is acidic or basic?
Acidic.
A lot acidic or just a little bit acidic?
Just a little bit.
Like right in here somewhere, right?
Yeah.
Would you drink pH 6.3 water?
Probably.
That's probably what we do all the time. I mean, shoot, if you put lemon juice in your water, you're probably running that pH down to 2. Okay.
Yeah.
So it all depends on what the acid is, because if it's a really dangerous poisonous acid, maybe you don't want any part of it. But I'll bet most of us are drinking water that's a little acidic or a little bit basic. So we're surviving pretty well. Eli, did you get this number too?
I don't have my calculator on me. Well, at least not a second.
But are you confident getting that number? Do you see how we're doing it?
Yes.
Okay. All right, Kirsten, you confident getting that number?
Yeah.
Major idea. If they ask for pH, you better be using the H plus concentration. Don't put hydroxide in here because it's not pH. pH is based on H plus. So let's go find some other homeworks we had. So did we say that was acidic, basic, or neutral? I can't remember. I thought we said that was acidic, didn't we?
Yeah, just a little
Yeah, because the
bit.
pH was what, 6.3 or something you said?
Yeah.
And so which of these is the most acidic of these 4?
The last one.
Okay, this is most. Which one's the least acidic?
The first one? No. That one, 12.
Yeah. Do you see how by comparing pH of 4 different solutions, you can rank them, right?
Mm-hmm.
It's another advantage. A pH scale provides a common scale where you can compare one solution to the next. So, let's see, where's the homework? Okay. All right, let's go find another one. I'll tell you what I'm gonna do. I'm gonna shut up for a few minutes, go get some more coffee. Okay, I want you to work 29. Copy 29. All right. So I'll tell you what. I'll do one. Let's see. I'll put my initials on this one. ED. Eli, which one do you want to do? B, C, or D? You cannot make a mistake. No bad choices here.
I'll do C.
Okay. Kirsten?
It doesn't matter.
Which one's your favorite, B or D?
B.
Okay. And so why don't we all do D? You should come up with an answer for D. Okay. I want to take a few minutes. I'm going to get some coffee. I'll be back in a few minutes. All right, let's see here. Let me try to do mine first. Okay, what did I have? I had pH 6 and pH 8. Okay, different ways to think about this. I'm going to try to answer mine this way. Okay, so I got pH 6, pH 8. Let's see here. pH 6 is right here, and pH 8 is right here. And the thing I'm noticing is that H plus, this compared to that, is 10 to the second difference, isn't it?
Mm-hmm.
2 powers of 10.
Yes.
And I want you to notice that's 2 pH units, isn't it? 2. Every time you jump 1 pH unit, your power of 10 changes by how much?
Is it a millionth of a? I'm confused.
Be careful now. If I jump just 1, how does your power of 10 change?
Oh, no one.
Changes by 10 each time. Yeah, do you see that? So if I go to here, it's 10 times less. If I go here, it's 10 times less, right? Here to here is another 10 times. Here to here is another 10 times, which means if I went from here to here, it's a difference of 10 to the third or 1,000, right? 1, 2, 3. Y'all with me?
Yes.
So I think my answer, I'll go back to my question, by what factor of 10? I think this factor of 10 is 10 to the second, because the change in pH is 2 units, 2 pH units. That's how I answered that question. And did you answer question 29E? 29E is a bonus question. You know there's bonus on here. 29E is which one is more basic? Like you have to tell me which one of your two is more basic. Okay, that was E. All right, any questions? Because I'm going to call on Kirsten next. Anybody got any questions?
Mm-hmm.
All right, Kirsten, what do you think on yours? 10 to what power?
To the first.
Okay, why do you think that?
Because from 5.5 to 6.5, it only changed by 1 unit.
1 unit. And so go back. See, you're exactly right. What you said is perfect. Okay. So you're going from here down to here, aren't you?
Mm-hmm.
Right? And that's the same gap as going from here to here. So it's how many powers of 10?
1.
Yeah. Okay. Eli, what about yours?
It'd be 10 to the negative 2.
Okay. Yeah. Well, or what did they ask the first or the
Larger to smaller should be negative instead of positive.
Yeah. Okay. Okay. I'm gonna still say it's sort of like absolute value, 10 to the second, right? That's not the right term, not negative. But it's a factor of 100 difference, right? Just like on mine.
Yeah.
Okay. Let's see. What do we get on this one? Oh, wait, whoa. That's hydroxide. That's not H plus. Huh. So how do we answer D?
I mean, first you find the H's, which would be
Okay. All right. So let's do D.
12.
H plus is which one? What's this one?
10 to the negative 12.
Okay. What about that one?
It's 10 to negative 11.
Okay. And what power of 10?
1.
1.
Okay. 10 to the 1. Okay. Y'all okay with that? Okay with your answers? Okay, so each one of us has now got to go back and we got to say which one is more basic. Okay. And we'll go back and I'm going to choose which one's more basic. Let's see. Kirsten, what did you say was the pH of neutral?
7.
Okay. So I think that if you're larger, you're more basic. I think this is more basic. Kirsten, what about yours? Which one's more basic?
The pH 6.5.
Okay.
No. Yeah.
Wait, don't change your answer. It's too late. I already circled it. Right. Right. I mean, hey, so Kirsten, I got to ask you, is 6.5 basic or acidic?
It's acidic.
But it is less acidic than this guy, right?
Yeah.
And saying that you're less acidic is the same as saying you're more basic. Remember that yin and yang thing we had? Okay, they go together like that. All right, Eli, which one on yours is more basic?
The first one, the 10 to the negative 8.
Okay. On this one, which one's more basic?
The first one.
Yeah.
Yeah, we could just vote that one because this number is bigger than that one, right?
Yeah.
And the one that has higher hydroxide concentration will be more basic. How do y'all feel about pH?
Okay.
Good.
Okay, like a confident okay, or okay, I hope I don't see it again.
Like, I understand it, but some of it's a little bit still confusing.
Okay. All right, we got a little bit of time. We can look at
Okay, so my biggest question is
Yeah.
on the pH table, when it's 1 through 6, it's
Let me go back
acidic.
to
I
this.
know that.
Yeah, let me clear this mess off. Hold on one second. It's all ink. Okay, go ahead. Ask your question again now.
Okay, you see where above pH it has H plus.
Right. So this is the H plus concentration that corresponds. Yeah.
So on the other end, does that mean that's OH or no?
No. H plus all the way down the line.
Okay.
So if we were really bored, and I would recommend this if you're really bored, we could add another column. Hydroxide. What hydroxide would this be?
I'm sorry, which one?
In other words, on this one, what would the hydroxide be? H plus
13,
you have 13. You with me? What would this one be?
12.
You see where I'm going, right? What would this one be? 10 to the minus 6.
Yeah.
This would be 10. You with me? When I get all the way down here, this would be 10 to the minus 1. Yeah. This would be 10 to the minus 7.
Yeah.
See how this times this and this times this and this times this is always 10 to the minus 14, right?
Mm-hmm.
Always. Yeah. So it turns out, Kirsten, that you can either look at acid-base chemistry from the eyes of hydroxide, or you can look at acid-base chemistry from the eyes of H+. It's just that traditionally over the years, they've decided long ago to look at it through the eyes of H+. So that means we have pH meters. We have pH paper. We don't have POH meters, and we don't have POH paper. We have a pH paper.
Mm-hmm.
But we could have had POH paper. It's just that the person who did H+ beat us to the punch. And so the person, and I got to tell you, the guy who invented pH meters, he got stinking rich, as you could imagine. So he retired long ago. I think it was at Caltech.
Mm-hmm.
So it's a way to measure pH in solutions. Let me see. Is there any homework? I don't want to keep you here because we decided on an hour. We decided to do this. Let's see. That stuff was from lecture. Any more pH calculations you see? I don't know if you see any more. You see any more? Well, anyway, so I'm assuming, I mean, we can do this one. Let's just end on this real fast. Let's do number 30. Some more practice. And y'all do know that the answers are posted, right?
Yes.
Okay. Right, Kirsten, you know where they are? The answers?
Yeah.
Okay. All right. So let's see what we're going to do here. We got 3 choices. Kirsten, which one of these 3 do you want to work?
HCl.
Okay. So they're asking for hydrogen ions. Okay. Eli, which one do you want to do?
Honestly, I don't know how to do those. So.
Well, then name your poison. Which one sounds like an exciting adventure?
I guess the second one.
Okay, good. All right. Oh, good. I'm glad you saved that one for me because I was looking forward to doing that one. Okay. All right. Let's see. Lowest concentration. First thing we got to do. Don't you? have to agree that this guy is an acid or a base. Which is it for this guy? Kirsten, that was yours.
Yeah.
Is this guy an acid or a base?
I would assume acid.
Why do you think so?
Just because I see 0.1.
No, I'm not convinced because I see 0.1 over here and I see 0.1 over there.
I know that's.
I know. Okay, so we got to do HCl.
Oh, I see a H in there.
Oh, yeah, I see the H, right? Don't
Yeah.
see the H? And H's normally mean what?
Acidic.
Okay. So that means this guy, Kirsten, is covalent or ionic?
Let me see. Covalent.
Yep. Yep. So that means this guy will fall apart in water. Because he's an acid, he falls apart, and it makes ions. What ions does this guy make?
Hydrogen and
Chloride ion.
yeah.
Right? Okay. Eli, what happens with yours? Your guy will make ions. What ions does he make?
Sodium and hydroxide.
Okay. And on mine, let's see. You got to help me with that one. What ions does this guy make? Stuck. I'm really stuck now. Looks like it would be an acid to me. I mean, do y'all think it would be an acid? Yeah. What ions do we make?
H.
Uh-huh. How many of them?
2.
It's got 2 of them. 2 of them. And then what else?
Sulfate.
Uh-huh. You see that idea? 2 negatives and 2 positives makes no charge, right?
Yeah.
All right. So now let's deal with this number right here. Let me change my color. Let's see. I got to think this through. Which of these has the lowest concentration of hydrogen ions? So what I got to do is I got to find the molarity of H plus for this guy, whatever it is. Huh. Oh, we got to do pure water. We got to compare pure water in our list too. Let me think. Well, let's see. This guy is 0.1 moles of this guy in 1 liter, right? And I want this guy. That's going to be the moles of H plus in 1 liter, right?
Okay.
What do y'all think? You with me?
Yeah.
So I got to do some stuff here. I got to do some stoichiometry. I want that to go away. That's going to have to go on the bottom. I want that to come in. That's going to have to go on top. But I got to put some numbers in here. What numbers go where? Y'all got to give me some numbers.
H.
How many H pluses in one of these guys?
2.
So what's my H plus concentration? What would this number be then? Down here.
Is still
2 times that, isn't it? Right?
yeah.
So that means this guy is 0.2 molar H plus. All right, let's go up and do the other ones then. What do you think on yours? Kirsten, what about yours?
0.1.
Mm-hmm.
And then
But your guy is 1 to 1, isn't he?
yeah.
So do we have a multiplier like a 2 here?
No.
So we're just done. That's it. When the guy is a simple acid like that, and there's only 1, and we don't have a 2 or a 3 in front, it's just 0.1 molar.
Okay.
All right. Eli, you had a little bit more work on yours. What do you think? You got to get molarity of hydroxide first, Eli. So what do you get? Same argument, okay? Sounds no chart here. Okay, same argument. Where this is 1 to 1, right? I get 1 and 1. So if this guy is 0.1 molar, then what would this guy be? You can write it out the same way like this. We can write 0.1 moles of NaOH per 1 liter. And we can do NaOH on the bottom and hydroxide on the top. And that would be a 1 to 1, right?
Yes.
So what do you want for a number for hydroxide here?
I mean, percent hydroxide would be 0.1.
Okay, but the good news is, this guy is related to this guy, isn't he? Because we're talking about a glass of water, aren't we?
Mm-hmm.
Isn't this guy times that guy equal 10 to the minus 14 in a glass of water? Okay, so what does this have to be then? If it's this for this guy, what does this one have to be? So you got some math that looks like this. I got 0.1 times x equals 10 to the minus 14. And so what do we get for x? Which is my molarity of my H plus.
Is it?
Wouldn't it be 10 to the, like, I know the 0.1, 10 to the negative 1.
Correct.
Other one would be 10 to the negative 13.
Correct. Done. Yep. We got one more. We got to add water to this, and then we can make a comparison. Okay, here's the number for this guy. Here's the number for this guy. This guy is 0.2. That's the number for that guy. What is the molarity of H plus in plain old water? Clean, pure water. Kirsten, what's the pH of pure water?
7.
How do you know?
I guess you said pure water. Oh.
I said pure water. That's what I said. Yeah.
Yeah, and so I assume it wouldn't be acidic or basic.
I assume that too. So that means the pH is going to be neutral, isn't it?
Yeah.
Right. And so what is our H plus concentration in pure water then? If the pH is 7.
7.
pH is 7. What's the H plus concentration? See that?
Yeah.
Okay, 10. I didn't hear you say 10 to the minus 7. That's what I was waiting for.
Oh, okay.
Molarity. I wanted the molarity is what I wanted from you. Okay. So that means pure water is 10 to the minus 7. Okay, that's pure water. All right. What are we supposed to do? Which of these has the lowest? Which one's got the lowest H plus?
The lowest?
Yep.
Is it HCl?
Look at the numbers.
Like, which one is more acidic or more basic when you say that?
Well, you tell me. If it says lowest H plus concentration, is that the most acidic or the most basic?
Most basic.
Right. So which one do you like?
So it's NaOH.
You betcha. Done. Yep. This guy's an acid. This guy's an acid. And the fact that he's 2 means this one's more concentrated than that one. And pure water is pH 7, so we know he's not acidic or basic. That one has got to be the most basic, which is the lowest hydroxide. Eli, what do you think?
Yeah.
Now I'm prepared to call it a day here, but I'll be happy to answer any questions you have before we leave. Because we all agreed to an hour.
Okay.
I will be there today at 4 o'clock. So if you go to that link, it'll be a Q&A at 4 o'clock also today. So.
Okay. I have a question.
Go ahead.
The study guide.
Which one?
Or the study exam. It was something on the outline.
Okay. Hold on. That's one of the things I got to work on when I get off here. I got to go work on that. Where was it?
Okay.
I think I know what you're talking about. Hold on, let me find the website. Okay. So if I go to the website, I think I know what you mean. Here, go here.
Yeah.
Oh, that right there.
Yeah.
Okay. All right. If you go back in time, back in 2015, which is the last time I taught this class,
Okay.
I gave my students this. And it was the thing that I used to write the final exam.
Mhm.
Like I went back and looked over all that we had done, and I said, yep, I want to ask him that, or yes, I want to ask him that, or no, I don't want to ask him that. And I put it all on one piece of paper. Okay. And so when I write your final, I'm going to look at that piece of paper and I say, yes, no, no, yes, no. I mean, in other words, these are the things you're going to be worrying about. So Kirsten, that's something that I hopefully will have done today. I certainly will have done by time for tomorrow's lecture. So it'll help you decide what you have to worry about. Okay.
Okay.
So don't look at the 2015 one because it's different every time I teach the class. It's different. Okay. You all have tests. So I tell you what I'm going to do. I'm going to scroll back to the notes. I'm going to scroll back through the exams that we took. I'm going to scroll back through the quizzes that we took, the graded assignments, and I'm going to say, yeah, I wasn't happy with their answers. I think I want to ask them again, or I'm going to say, I want them to show me that they know this idea. So I might ask it again. There's all different things that will go through my mind. But I think that'll help you. Okay, that's what you meant, right?
Yeah.
Okay. Yeah. So does that answer your question about that?
Yeah.
Yes. Don't look at this. This is old, outdated. Okay. Yours will be posted right here. I'll have a link right here. Okay.
Okay. Thank you.
You're welcome. Eli, you got any more questions?
Nope.
Okay. Well, I am as close as email and as close as a phone call. Otherwise, I'll see y'all later.
All right.
Take care. Stay dry out there. All right.